Go for deploy.
Other speed, drifting to the right, roll. Contact right. The Eagle has landed.
Hey guys, Tori here from Overlook Horizon. We're back. Oh, you just edited it in post. Everybody watching the replay is going to have no idea what just happened because I'm clipping that out. It's going to be edited, and we're just getting a replay. Or, we're going to edit the whole first section out. We're here live. It is November 5th, 2020, and it is now 6:04 p.m. Eastern Daylight Time on the East Coast. We're ready for a SpaceX launch now that we've sorted out our issues. Ready for SpaceX to launch GPS 3-4 into medium Earth orbit. And as I started saying, the medium Earth orbit is not one that you usually hear about very often because it's almost exclusively used for GPS satellites. So that's what we're doing today. Now I'm all flustered because we had the technical issues, but I'm good. We're going to get the train. Get the train back on. Oh, I might have to fix the camera in the other, when I do my, hey guys. I might have to fix the camera in that one too, in that shot. We might have to fix the camera all over the place. Oh no, this is going to be a disaster. Okay, well, I'll try to catch it everywhere we go. Let me try to get the train back on the tracks and tell you about today's mission. I blame it. It's blaming the space lobster is really, that's what I blame here.
Space lobster ate the T-Teb. That's the answer.
That's the answer. It's the space lobster that's on. Should we do a take 3? No, we're not doing take 3. I'm just kidding. All right. Well, I am excited because we got some new stuff today. We've got a new camera, obviously, which is causing all kinds of problems, but we're going to sort through them. We've got some new tools, which I'm excited to share with you, which are from flightclub.io. We're going to have some telemetry information right here. Some fresh telemetry information for the actual feed here today. We'll actually be able to see velocity, acceleration, and throttle for both stage 1 and stage 2, along with up here is the fuel level for the actual rocket itself, stage 1 and stage 2. So we'll see how much fuel is in the rocket. We're going to see the telemetry. So this is kind of exciting. It'll be nice to see some of this stuff. And I will say, it's something we got to pay for, which is natural. You should pay for it because Declan over at flightclub.io does an awesome job for it. And so if you want to help support stuff like that, so I can do telemetry stuff like that, he's giving it to us for free today to test it out. But if you want to see this kind of stuff incorporated into the live stream, consider becoming a Patreon member or a member of the YouTube channel. And we can actually pay for stuff like that and incorporate it into the telemetry stream. All right, so let's try to get the train back on the tracks and see if I can go through my couple of pre-launch stuff, and I'll tell you what's up for today because it's looking pretty good. So today's mission, obviously, like I said, is GPS 3 vehicle number 4 that they are launching into medium Earth orbit. Now, if you're not familiar with medium Earth orbit, it's in between low Earth orbit and geostationary orbit. So medium Earth orbit looks something like this. This is the NAVSTAR constellation here. You can see they kind of crisscross around. They're at an inclination, so they're at a bit of an angle here. And medium Earth orbit is, the inclination is 55 degrees, by the way, but the medium Earth orbit has an orbital period of about 12 hours. So geostationary orbit has an orbital period of 24 hours, means it goes around the Earth once every 24 hours, which is why it's geostationary, because it goes around the Earth the same time it takes the Earth to revolve itself. So that's geostationary orbit. This is medium Earth orbit, which has an orbital period of 12 hours, so half that of geostationary orbit. And then, of course, we've got the low Earth orbit, which is where Starlink is, which is where a lot of lower Earth observation satellites are down here in low Earth orbit. So we're going into medium Earth orbit here. Altitude is about 20,000 kilometers in altitude is where it's headed. Somebody have to do the metric conversion there for me. Weather today is looking fantastic. We were originally slated for only a 60% chance of launch, 40% chance of violating launch conditions, but we're actually up to 80% chance of launch and only 20% chance of violating launch conditions, because this forecast, which came out yesterday, is actually outdated now, and we're in better shape. So things are looking good from a weather standpoint. I do want to acknowledge a couple people because I saw Kimmy joined and became a member of the channel. Thanks, Kimmy. Appreciate that. GVA Morning Show, thanks for the super chat during our technical issues to check the OBS levels. I'm glad we got that sorted out now. Helmet, thanks for the super sticker. Give me the big thumbs up, I'm assuming, once we got it sorted out. Framrick, our awesome moderator there. Thanks for the super chat. Superb beginning, Tori. Didn't notice anything out of the ordinary for the new telemetry. Yeah, all right. Well, we'll get it sorted out. It's day one. Justin Ford, thanks for becoming a member on the channel. And Anita, thanks for becoming a member on the channel as well. Appreciate the support there. Stuff like that is what's going to help me incorporate those new telemetry streams. I'm excited to see how well that works here. So, a couple people have asked what time we're launching here. As always, we've got the countdown clock right up here. We're about 13 minutes away. SpaceX is probably going to be going live here soon. Actually, they're going live right now. Let me show you real quick before they go live. I want to show you the flight path here today. So it is going to the northeast. Drone ship landing for the first stage and fairing recovery attempt as well today. So hopefully we should get we should know about that today, because deployment is about an hour and a half after launch. We got lots of time after launch to chat it up. We're gonna play around and take a look at some stuff, but we'll get after it here. And let's see, SpaceX is live here, so let me switch over to the stream, and we will listen in to what's new with them.
Florida. My name is Jesse Anderson, and I'm a lead manufacturing engineer here at SpaceX. Welcome to our webcast coverage for GPS-3 Space Vehicle 4 for the Space Force. The U.S. Space Force satellites provide mission-critical global access, persistence, and awareness for our national security and have become vital to our global community and world economy. The Global Positioning System, or GPS payload, will provide a diverse range of navigation and timing services for both civil and military purposes. Today's payload will join 31 operational GPS satellites already on orbit and will help to serve over 4 billion users worldwide. And as you may recall, about a month ago, we stood down from Falcon 9's launch attempt of this mission due to an auto abort during engine ignition caused by early start behavior on 2 engines. This was a good abort by Falcon 9. The rocket did exactly as it was programmed to do when the data indicates something doesn't look as we expect it to right before liftoff. We sent those 2 engines to Texas for further testing, and it turned out that there was a blockage in a vent passage that leads to a relief valve on the gas generator. The blockage was caused by a masking lacquer residue that had hardened during the build process, but once we removed it, the gas generator was restored to normal behavior during subsequent testing. This was a really great find. It allowed our teams to fix something that is very subtle but can have some negative impact on the engine behavior, as well as allowed us to make sure that we can prevent this from happening again in the future. The 2 engines which first exhibited the early start behavior on this booster were replaced with new ones, which were tested again during our full duration static fire. Both engines look great, and the rocket is healthy for flight today. So let's take a closer look at the vehicle that will launch the GPS-3 satellite. On your screen is a view of Space Launch Complex 40 with Falcon 9, our 2-stage liquid-fueled launch vehicle getting ready for liftoff. Falcon 9 stands 229 feet or 70 meters tall, which is slightly taller than a 21-story building. The bottom 2/3 of the vehicle is a brand new first stage. Its job is to accelerate the vehicle all the way to the edge of space, where it will drop off the second stage carrying the payload. Tonight we will be attempting to recover the first stage on our drone ship, Of Course I Still Love You, and there you can see it on your screen right there in the middle of the Atlantic Ocean. What's really exciting is that this specific booster is planned to support the GPS-3 mission next year, which will be the first time that the U.S. Space Force has agreed to fly a flight-proven booster. About 2.5 minutes into flight, the first and second stage will separate, and the second stage will ignite its single Merlin vacuum engine to carry the GPS satellite to a highly elliptical orbit. Separation from second stage will occur approximately 4,000 kilometers above Earth, and then the satellite will perform berms to raise its position to enter a circular MEO, or medium Earth orbit, and reach an apogee of approximately 20,200 kilometers above Earth. An apogee is basically just the furthest point from Earth, or the highest point that the satellite will reach in orbit. Inside of that structure on your screen, this is at the very top of the rocket, is where the GPS-3 satellite sits. And that structure is what we call the payload fairing, which is about 17 feet or 5 meters in diameter, and about 43 feet or 13 meters tall. This payload fairing protects the satellite from aerodynamic heating, loads, and contamination during ascent. But once we get into the vacuum of space, we no longer need this protection, so we will jettison the fairing halves to save some weight as the second stage continues with the satellite to its targeted drop-off orbit. The fairing halves we are using today are new, but due to upgrades being made to our recovery boats, we will be attempting to pick these halves up out of the water using our recovery vessel, Miss Chief, today. And there is Miss Chief on your screen, heading to the pickup zone. The large trusted structure next to Falcon 9 is the transporter erector, or the TE, and you can see that on your screens to the left side of Falcon 9. The TE is used to roll the Falcon 9 to the launch pad and raises it to its vertical launch position, as well as routes power, fluid, and communication to both the rocket and the satellite. Now let's get a status update on the vehicle.
Good evening from the webcast desk here at SpaceX headquarters in Hawthorne, California.
Hey, John.
I'm John Insberger, Falcon 9 Principal Integration Engineer.
We love John.
It's been a quiet countdown during the day, working relatively few minor issues. The teams are ready to launch as we approach T-minus 8 minutes to liftoff. Now we're launching from Space Launch Complex 40 here in the dark of Cape Canaveral. This will be our third GPS launch, and all of them have been from this launch pad. Now, the spacecraft team performed functional checkouts of the GPS satellite during the day, and the Falcon 9 team began their final checks of the launch vehicle at T-minus 2 hours. At T-minus 38 minutes, the team concluded their electronic go-no-go poll and gave the OK to proceed into propellant load and launch. The team then began loading propellant at T-minus 35 minutes. We load the propellants as close to launch as possible in order to keep them cold. Both the first and second stages use the same propellants, as the second stage Merlin engine is very similar to those on the first stage. This allows us to make the second stage like a shorter version of the first stage, and this commonality is one of the many reliability features in the Falcon design. Now, our fuel is a refined form of kerosene known as RP1. Our oxidizer is super chill liquid oxygen called LOX. I mentioned keeping the propellants cold. We chill the liquid oxygen as cold as we can get it, allowing us to load more into the booster. Now, currently the second stage is fully loaded with RP1 fuel, and the first stage continues loading for another minute. Liquid oxygen is also loading on both the first and second stages right now. We're also loading helium into storage vessels on the first and second stages. During flight, we'll take this cold helium, run it through heat exchangers on the Merlin engines. That heats the helium up, and as it expands, we use it to fill the empty volume in the propellant tanks that's created as the engine pumps pull the propellant out of the stages. Now, you just may have heard a moment ago, we're inside of 7 minutes. We have begun engine chill in. That will cool the turbopumps and avoid thermal shocks when we start them at T-minus 2 seconds as part of the ignition sequence of the Merlin engines. The spacecraft team has transitioned the GPS payload to internal battery power, occurring just as we came on the air at T-minus 13 minutes. That is their last major activity required before launch. Currently, the range is green, ready to support. The weather, the only thing we've really been watching is the ground winds. They've been marginal, but for the moment, everything continues to look good. We've got about 17 miles an hour from the east. That's within limits. Now, if we do have to call a hold on today's launch, we have a backup opportunity tomorrow with liftoff time scheduled a few minutes earlier at 6:20 p.m. Eastern Time. Now, all systems continue to be go for a liftoff just past 6:24 p.m. Eastern Time.
As we mentioned earlier, today's mission is for the U.S. Space Force launching the GPS-3 Space Vehicle 4 payload. Now we'll hear from the Air Force's Lieutenant Colonel Margaret Sullivan and Lockheed Martin's Tanya Ladwig for more information on tonight's payload.
Might have to turn... Yeah, they got some music on there, so I got to turn that down. So that's good, though, because it gave me a chance to chat here. A couple things. The payload fairings, I think they're doing a water catch today because Miss Tree, the one that had the broken net a couple of weeks ago, is still docked in Florida. So only Miss Chief is out there for recovery right now for a payload fairing. And I don't think it's a catch attempt. I think they're going to soft land it and then pick them up out of the water, I believe is the plan. He did say concern was going to be ground level winds here, and you can see as of the 6 o'clock hour about 20 minutes ago here, 16 mile per hour winds at the Cape, within limits, but it's getting high. It's getting a little bit high, so you can see it's coming off the Atlantic Ocean there a little bit from this system up here. Once this loads, coming right into here, so we're getting some ground level winds is the concern. That could see a possible issue there. And what would the liftoff winds was part of the mission execution forecast here. So that was one of the concerns, was liftoff winds, also cumulus cloud rules. But I don't think we were having much of an issue with cumulus clouds here. It's pretty wide open here right now on the radar. So we're looking pretty good. In case you missed it earlier, we've got some cool telemetry that we're going to show here. Hopefully it all works okay. I tested it before. This is going to be the first time. Hopefully the beginning of the broadcast is not an indication of what's going to happen here, but we're going to test some of that out shortly.
Everything continues to be go for launch. What we're watching right now is the strongback has just retracted to the pre-launch position. It's about 2 degrees from the rocket. At liftoff, hydraulics will move the strongback the rest of the way back about 45 degrees from the rocket. Now, first stage fuel loading did complete at T-minus 6 minutes.
Strongback retracted.
We're continuing to wait for first stage liquid oxygen load to finish up in about half a minute here, followed a minute later by second stage completion. Now, a minute before liftoff, you'll hear the announcement Falcon 9 is in startup. That means the rocket's own internal computers are controlling the launch countdown on the rocket. Once the engines are confirmed to be at full power, the flight computer on the second stage will then command the ground hold downs to release the rocket right at T0. The satellite team continues to monitor status and health of the GPS-3 located inside the fairing that you can see on the screen. And right now, all systems are go on the satellite. The range is green for launch.
That's good. That's
and
good.
We have, it sounds like in the background, we heard that stage 1 lock closeout complete, so we're on time. And the good news is the weather is looking good still. Ground winds are in limits, upper altitude winds are good. So as a reminder though, if we don't have a launch today, we have a backup opportunity tomorrow with liftoff time scheduled 4 minutes earlier than tonight. But right now at 2 minutes and 20 seconds and counting, everything continues to go well. Waiting now to hear stage 2 LOX load completion.
Now this is Launch Complex 40, Space Launch Complex 40, which has awesome pad microphones. So make sure you got good headphones in or good audio because it's going to sound awesome at liftoff time. I do also want to say thanks to Jonathan Calvert and David Bune.
Stage 2 LOX closeout.
Over on Facebook, sent over some stars.
Minus a minute, 51 seconds, and we've heard the stage 2 LOX loadout call.
Those stars are pretty new. I don't really know how they work, but thanks for sending them over, guys.
Since we're finished loading liquid oxygen onto the second stage, we have to drain the line back that runs the length of that strong back you can see next to the Falcon 9. And as we do that, we'll vent off pressure, and that'll create the large white cloud that you see around the strong back and maybe the rocket, depending how the wind's blowing. That's nominal. That's what you see right there.
Last
just
big vent.
Bringing everything back down the line as we're closing out propellant and pressure loading on the Falcon 9.
There we go. Now we can hear the pad mics. There we go. It's a last big vent. They're draining the lines in the
activity. We're
strong
waiting
back.
for the call out that Falcon 9 is in startup.
Here we go. Get your headphones ready.
Falcon 9's in startup.
Great
There it
audio
is.
coming up.
Computers have taken over the Falcon 9. We're pressurizing first and second stage tanks for launch. Waiting for final go.
The mission director, stage go for launch.
Mission director has given the go for flight. Everything continues to look good. Pressurizing the tanks one final time here to get ready for liftoff. But right now at T-minus 30 seconds and counting, all systems are go for the launch of Falcon 9 with GPS-3 Space Vehicle number 4.
Here we go. Let's do it. Here's our view. Hopefully the telemetry all works okay. Fuel here. Telemetry here.
T-minus 15 seconds.
Falcon 9 configured for flight.
Never used this before. Hopefully it works.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Go Falcon. Go GPS.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
"30 seconds into flight, propulsion says the Merlin 1D engines are nominal. We're on trajectory and preparing to throttle down in preparation for maximum dynamic pressure."
All right.
And we're heading into the throttle bucket as we power down the Merlin engines.
Watch the
And
fuel. Look at the
throttling
fuel
back
come
up
down.
now. And when the engine's back up at full
Vehicle is
power,
supersonic.
and we have gone past Mach 1. Waiting now for Max Q call out.
The vehicle is experiencing maximum aerodynamic pressure.
Guidance engineer reports we're passing through the
getting
period
real
of
low.
maximum aerodynamic pressure called Max Q. From here on, as the speed picks up, the atmospheric density decreases and the loads are reduced on the Falcon 9 vehicle. Propulsion power
There we go.
continues to look good. The trajectory looks good.
Getting a little bit of wind noise here.
MVAC engine chill started.
The engine chill in call out on the MVAC second stage engine indicates we've begun chilling that turbopump like we did with the first stage engines, getting ready for ignition of the upper stage engine. Now coming up in just over 30 seconds, the usual 3-sequence event that'll happen in rapid succession. Main engine cutoff will shut down the 9 Merlin 1D engines you can see glowing there in the night sky. Stage separation, and then we'll get startup of the second stage engine.
All right, we're coming up on separation here. Watch the stage 1
Nice view
telemetry.
from the ground camera looking up at the 9 Merlin 1D engines on the business end of the Falcon 9 first stage.
Stage separation confirmed.
There we go.
MVAC startup.
It's like our telemetry is a little behind the video feed.
So we've had a good separation. MVAC up on power. On the left screen, the first stage continuing to coast downrange as it begins to deploy those large titanium grid fins. Trajectory continues to look right down the middle.
Both stages are following nominal trajectories.
Guidance confirms we're on nominal trajectory with both stages.
Acquisition of signal, Maryland.
Maryland reports they've got signal from the second stage. Next event coming up is payload fairing separation.
Separation confirmed.
A nice view from the camera looking forward. The GPS-3 satellite with the 2 payload fairing halves separating. Everything continuing to go well on this mission. 3 minutes and 42 seconds into flight. First stage continuing to coast to apogee, headed downrange. Second stage engine at full power. Everything's looking good with the MVAC engine. Right now, trajectory heading us to where the Bermuda ground station can hear us. We've heard the call out, acquisition of signal. Bermuda now getting the telemetry from the Falcon 9 second stage. So 4 minutes, 8 seconds into flight, everything going well on the flight of Falcon 9 with GPS-3.
You see a little bit of thruster
Both
firing.
stages continue to follow nominal trajectories.
on the left screen there, those
And
little
at T
flashes
plus
of white.
4 minutes and 20 seconds. We're currently in the first of 2 planned MVAC burns. And we just passed T plus 4 minutes and 23 seconds, and that's actually when the first stage reaches apogee of 120 kilometers, almost 400,000 feet. At stage separation, the first stage velocity is about 2,200 meters per second, or 5,000 miles per hour. So right after stage separation, the first stage, still moving at such a high velocity, continues to raise its altitude as it coasts for a couple of minutes. Basically, the first stage almost doubles its altitude from stage separation, which occurred at about 69 kilometers or 226,000 feet, to when it reaches apogee, and then it starts its return back to Earth. And again, apogee is the highest point, or the furthest that it is away from Earth in the trajectory of the first stage. Now, the next major milestone that you'll be able to see on your screen is the first stage's entry burn. For the entry burn, we relight the center E9 engine, and then partway through we relight the E1 and E5 engines, so that we have a total of 3 M1D engines, helping to slow the vehicle down as it passes back into the Earth's atmosphere.
Michael says, interesting how much fuel is left for the landing. Always wanted to know that. Yeah, watch how much. So we haven't even done entry burn yet, but watch how much fuel is left in that first stage booster when it lands. It'll be almost nothing.
And you heard that call out that both stages are looking good. T plus 6 minutes. We're about 20 seconds away from that entry burn on first stage. And it is nighttime over there on the East Coast, so hard to see that first stage on the left-hand screen, but once entry burn begins, it should light up that screen. We should be able to see first stage pretty well.
Yeah, we can't see much on the left there, but get it soon here. Oh, here we go. Here's entry burn.
Stage 1 entry burn startup.
And there's that entry burn starting up.
Stage FTS is saved. Stage 1.
You could see the plume started off small and it got a little larger, and that is because we started with one single engine, added a couple engines for a total of 3 for this entry burn.
Stage 1 entry burn shut down.
And that concludes the entry burn. Next up, we do have a couple major milestones happening back to back. The start of the landing burn for first stage, followed immediately afterwards by SECO-1 on second stage. And SECO, which stands for Second Engine Cutoff, is where we shut down the MVAC engine to allow the second stage to coast, which preserves the fuel until we need it for the final burn to take us to our targeted orbit for the GPS-3 satellite. Then about 25 seconds...
Cape, stage 1 expected.
Then about 25 seconds after SECO-1, we'll hopefully have a nice view of the first stage touching down on, of course, I Still Love You. And there's that drone ship on your left-hand screen.
Notice how the...
Stage 2 has entered terminal guidance.
Stage 1 still has acceleration happening.
Stage 1 transonic.
And that's basically the air resistance there, because it's the engines aren't firing on stage 1 right now.
Two events. Again, the landing burn, followed by SECO-1 on second stage, just a couple seconds after that landing burn begins.
Stage 2 FTS is saved.
We're waiting for the drone ship camera. We'll see if we get clean video feed.
Stage 1 landing burn.
There's landing burn. Our throttle's not showing. Where's our throttle? Get the throttle up. There it is.
And SECO.
And there we've had SECO, waiting for confirmation of good orbit as first stage returns to Earth.
Stage 1 landing leg deploy.
Landing legs.
Nominal parking orbit.
There's good
Here
orbit.
comes.
And at the same time, we have touchdown of our Falcon 9 on, of course, I Still Love You.
All right.
And again, that did happen at the same time, so we did have SECO and good orbit of our second stage.
2 expected.
And there you can see on your left-hand screen, first stage landed on, of course, I Still Love You. This marks the 16th Falcon 9 landing just this year and the 64th of all time. And we're looking forward to seeing this booster take its second flight on the next GPS mission next year. Now the second stage vehicle has now entered its first coast phase, which will last about 54 minutes, and we will light that MVAC engine for a second time shortly after T plus 1 hour and 3 minutes. So we're going to take a quick break, and as always, we leave you with an animation so that you can keep an eye on where that second stage is throughout the coast phase. So we'll see you back here at T plus 1 hour and 2 minutes.
All right, so we've got some time here now to chat it up a little bit. But take a look here. Take a look at our telemetry feed. Look at how much fuel is left in that first stage booster. Almost nothing. You can see just a sliver of green right here and just a tiny bit, I can't point that far, a tiny bit of blue up there. Even the second stage, not a lot of fuel in there. And we're going to do another second stage burn a little bit later. So in about 50 minutes from now, 50 minutes, there will be another burn on the second stage. So there we go. What'd you guys think of the telemetry? I saw some people liked it. There were a couple people that did not like it, but I thought it was pretty good. It's a little bit, it's hard to calibrate because the telemetry is calibrated to what we're seeing on the screen, and a lot of times the audio callouts you hear happen before the video feed. So I calibrated the telemetry to what you're seeing on the screen. I figured that'd be the most, that would make the most sense. But there, something new, something interesting and different to see there that you don't normally get to see. You can kind of see the how the air resistance as it's coming back into the atmosphere is affecting the speed and everything. I thought it was kind of cool. It's pretty nice. Let's see. So everybody saw it from my house and says Scott. That's awesome. Great job. Telemetry was awesome. Says Steve. Thanks, Steve. Appreciate it. Only fumes left, says Michael. Yeah, it really comes down and it's almost nothing. Almost nothing. Look at this huge bit of, right there, liquid oxygen coming out of the vent port there, solidifying. Nice to see the G loads on descent, says JJ. Very interesting new display. Oh, good. I'm glad everybody liked it. I shouldn't say everybody. Not everybody liked it. I did see a couple messages that said this is horrible. I can't please everybody, all right? About 8 seconds difference with the SpaceX feed. Yeah, don't forget, SpaceX feed has to come to me first, and then it goes through my broadcast stuff, and then back to you. So it's always, my stuff is always going to be behind what the actual SpaceX feed is. Not by much, but 8 seconds sounds about right. Love the telemetry, says everything space. Awesome telemetry, peaks and Eric Boss, one of our YouTube members, said loved it. There's no margin left. There's no go around. Definitely. William got to see this launch from Boynton Beach, Florida. Awesome. Anita said, can't wait to see this booster come back into port. What's with the space snow? Most of that, so all the stuff that's around the booster there is, most of it is ice. And, because remember that booster is super cold. Even though it's, I don't know what the temperature is in Florida right now, but even though it's relatively warm in Florida, the liquid oxygen is negative 340 degrees Fahrenheit, which means that any water in the atmosphere that touches the surface of that booster is going to freeze, turns into ice. So then little bits of that ice can break off at different parts of the flight. It doesn't doesn't always just break off in one piece. That was one of the major reasons why they put that foam on the outside of the external fuel tank for Space Shuttle. Carrie said telemetry is a good thing. I enjoyed it. Well, good. I'm glad you like the new telemetry look there. Let's see, going back to a couple other comments here that we missed. Shouldn't stage 1 acceleration be very near 0 at the moment? Yeah, it would only be 0 like right at the peak of your apogee, and only just for a brief moment, because after that, basically any change in velocity that you're seeing is going to cause at least some acceleration. Most of that, when the engine's not going, most of that's caused by the atmosphere. So we're going to take a look. We'll go back and take a look at a replay here in just a minute. Why was telemetry showing 1G when the rocket should be falling, so 0G? So the rocket is still going to experience acceleration. You'd only have 0G if there's zero change in velocity. So if you're that stage 1, even though it's coming down, the speed change there is still imparting an acceleration force there. How can I tell when it'll be over Michigan? Should I be able to see it? I mean, we don't have, this isn't like Starlink, so we're not going to really see this. Let's take a look while we're talking about that. Let's go look at our simulated flight path, which we can actually play around with a little bit. So here's the simulated flight path from launch. Right now we should be, let's see if I can find it. This is also from flightclub.io, and let's see. I always have a tough time navigating this. I need to find a better way to navigate this. Where am I? Where are we? All right, so there's our launch. We should still be over here somewhere. Is this the live? Oh, I might not be showing this live. Let me pull up the live view here. It'll take just a second to get the live view up. I think I wasn't showing the actual live view. There we go. Oh wait, that's not it. That's the SpaceX broadcast. Maybe Flight Club isn't doing the live view, the live animation themselves anymore. They're just showing the SpaceX one. Because it doesn't look like it. But they're almost over the UK here now, so I guess we can go back to... We'll go back to the Flight Club globe that I had. Get this over here. So I can manipulate it a little bit. Alright, this will let me... Let's see, just getting this simulation here up so we can mess with the globe, and I'll show you the flight path again here. Alright, so now that we got this up here, we'll try this one more time. So right now, we're about... Let's see, can I do it? Well, actually here, we can kind of fast forward it a little bit, right? Nope, that's changing the warp speed. We don't want to change the warp speed. Well, right now we're about over the UK here. Right there. We can actually see it in the SpaceX broadcast here. You can see where stage 2 is right now. Stage 1 obviously has landed at this point. But heading over this direction, then we're going to do another burn here in about, what are we at, 40 minutes or so. We'll have another burn. All right, let's back it up. Let's back it up, and we'll show a little bit of a replay here. For anybody that happened to miss it, and I'll do the replay without my overlays. The audio, surprisingly, so usually the audio is amazing at this launch pad, but I gotta say, it wasn't quite up to par from what it usually is. So let's try this again. Let's get our replay text on so nobody gets confused. Dana saw it live from the balcony. That's awesome. I gotta get back down there at some point. All right, let's listen in.
6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Go Falcon. Go GPS.
Vehicle is pitching downrange.
Yeah, it was.
Stage 1 propulsion is nominal.
"30 seconds into flight, propulsion says the Merlin 1B engines are nominal."
So there we go. So I'm going to turn that down. We'll let it play out a little bit, but yeah, the audio just wasn't usually the audio at pad 40 is amazing, but it wasn't quite there this time. It was a little bit. It was kind of like my audio at the beginning of the broadcast. It was a little bit off, just a little, almost overmodulated or something. I don't know. I've seen better, but it's still great that we get the audio. Just wasn't that amazing. How can we hear it so close? I'm not sure. Well, they have microphones there, just like the camera. So they have a couple of pad microphones, especially at launch pad 40, although they just started putting pad microphones at launch pad 39A as well. Well, I shouldn't say they just started putting them there. They've likely had them there, but they just started feeding them into the audio broadcast. Because they use those microphones. As far as I know, they use those microphones for engineering purposes as well. Sometimes you want to hear what's happening at the launch pad. The audio gremlins are out tonight. I know. I always, you blame it on the Space Lobster.
That's the answer.
That's the answer.
Space Lobster, the T-Teb. That's the answer.
That is it. That's the answer, Tim. Space Lobster ate the T-Teb. So, yeah, the Space Lobster's all over the audio problems today, both from my broadcast and apparently for SpaceX too. I don't know why. Sound was way better than last time. I don't know. I can't remember which launch was which at one point, but we just had a launch recently that had amazing audio. But I don't know if that was last time or the time before. I can't remember. They all combined together. When's the next crewed launch? Says Dana. Next crewed launch is scheduled for November 14th, which is basically almost like a week, just over a week away. I do like these night launches because you can see, let's back that up a little bit. Oh, right there. Look at that. It froze right on that frame. You can really see the green of the T-Teb. I don't know why, but I love that part of it. The T-Teb, triethyl borane, triethyl aluminum is the igniter fluid. It's pyrophoric, meaning that it just has to contact oxygen to ignite. So that's what they use to actually ignite the rocket, as opposed to like a spark plug igniter or something like that. So they're using that T-Teb, and that's what that green flash is that you see just briefly. That's the ignition fluid coming out to ignite the engine. You can actually see it in the first stage view, looking up the first stage at the second stage engine bell, and then the second stage view, obviously looking at the engine bell on the way out. And we also talk about some people think that the rocket's braking, but it does this all the time. But this little bit here is called the stiffener ring there. Just helps provide support to it while it sits in that first stage there, and that breaks off intentionally every launch as soon as the engine ignites. So we'll see the triethyl. Oh, did I say it backwards? Triethyl aluminum, triethyl borane. Yeah, I said it backwards. Sorry. Triethyl aluminum, triethyl borane. Say it 3 times fast. Triethyl aluminum, triethyl borane. Yeah, I said it backwards, didn't I? All right, so we'll go into here, and you can see, so obviously the engine ignites, and then watch for the stiffener ring right there. See it break off? Actually, it broke off in a whole bunch of pieces that time, which was kind of cool. Sometimes it just peels off and goes into like 2 pieces, and that's it. But this time around, like, right, look at that. You can see it broke into like 1, 2, 3, 4-ish pieces there. And you can actually see, you can even see the first stage camera affected by the engine blast there until the second stage gets far enough away where it's not, the exhaust isn't affecting that first stage there. Charles Cornett, one of our YouTube members. Thanks for the support, Charles. Can you talk about why max Q is such a central part of every launch? Are the tolerances that tight that they have to throttle down for it? Yeah, basically, because you can get atmospheric heating if you travel too fast. You know, you get a lot of stress on the vehicle heading through max Q. So max Q is basically the point. So your pressure, your air pressure is at the highest when you're on the ground, but your speed is at the lowest when you're on the ground. And so as you go up in the atmosphere, your speed climbs, but your pressure decreases. And at those 2 points where, let's see, where you probably should do it from the same side. Your speed goes up and your pressure goes down. Right there is max Q. And that's basically, they go into what's called the throttle bucket, where they throttle down the engines to slow down a little bit so they're not just screaming through as fast as possible. Reduces stress on the vehicle, prevents atmospheric heating on the vehicle if you travel too fast. Well, actually, we can actually try that in Kerbal here in a little bit. But if you travel too fast going through the atmosphere, you can get speeding just like, or heating, I mean, just like you would get re-entry heating. You can get what's the opposite of re-entry? I feel like I'm gonna have another side carrot moment. You can get launch heating. Let's see, 17,000 miles per hour. Yeah, that's, well, 17,000 miles per hour is usually the orbital speed for like the International Space Station. This was, what did we end up here speed-wise? I can tell you, because we'll look at our telemetry. What are we at? 26,800 kilometers per hour, which should be pretty close because we're still in low Earth orbit. What does that convert to? $16,652 miles per hour. So it's almost 17,000 miles per hour. Pretty close. Orbitation heating. It's going to deorbitate. Right, it's going to deorbitate. Whatever the it's going to anti-deorbitation. During the anti-deorbitation maneuver, it can heat up. You get anti-deorbitation heatification. That's the problem. Pre-orbitation heating, as Gregorius correctly points out the correct terminology. Pre-orbitation heating. I like that. Okay. All the new people to the channel are very confused. All right, let me go back before people get confused. Let me go back to this view so people know that this is a replay. Pre-re-entry. Let's see. Okay, so I'm going to take this through, so here's our entry burn. We'll take it through landing. And then I'll show you what happens if you try to go through max Q without slowing down. What kind of camera are they using? You're talking about onboard cameras? I don't specifically know what onboard cameras they're using. It'd be great to find out. But I don't know. Look at just before 420, something flying past right to left. Is this like, are you just making me look at 420 because, or did you actually see something? I mean, it's going to be tough to see because I see nothing. Just before 420, he said. How much before? This little thing right here? Right there? That's just going to be like ice right there. I don't see anything else. You give me a specific timestamp, we'll take a look. We'll go back and take a look. But I see nothing else. Why can't we see the Earth? Well, right now it's the middle of the night. You can kind of see it in the second stage. You can see the sun a little bit right there. But we might get a view. Let's see. Let's go back to our live. Oh no, they're showing the animation right now. When they come back, I don't know whether the next burn is going to be in daylight. So when they come back, the next burn might be in daylight. Left screen, a light passed by. What in the world are you guys talking? Oh, right there. This is just going to be a little bit of ice right here. This little tiny bit here. Right there. That's just going to be ice. Notice how it comes right after the thruster firing. So that thruster firing, it imparts vibrations and a little bit of, you know, a little bit of tension on the vehicle whenever you fire the thruster. So you get thruster firing. It breaks this little piece of ice free. Just a little tiny piece of ice. No big deal. Everybody says they use GoPros. I wouldn't be surprised if they use GoPros. I mean, you can hook up a GoPro, but I have a feeling it's something a little more like native to the vehicle. I don't know. It wouldn't surprise me if they use GoPros, because they do use a lot of like just general consumer hardware, particularly when it comes to their computer systems. So a lot of like NASA computers were built to be radiation hardened, super expensive, but made sure that they could survive in space. SpaceX's view is, well, we're not going to pay to do all that. We'll just put 3 of them on board. The chances of 3 computers all having bit flips from radiation or something like that is pretty low. 1 certainly could, but if it happens and you get a bit flip, which is basically what happens if radiation hits a specific part of memory, it can corrupt a specific, basically like memory bucket, and cause a bit flip. So you've heard of like 0s and 1s for computers and things like that. If you have one of your registers that's supposed to be a 0 and radiation hits it, all of a sudden your circuit can go, just kidding, it's a 1 now, for no reason, due to radiation. So that's called a bit flip. Basically changes the bit for no reason. And if that happens, it can screw up all your data and things go crazy. But the way SpaceX deals with that is just by having multiple computer systems on board. So if one of the computers has that sort of bit flip, the other 2 computers basically, you know, kick it out of the club. And they're like, no, you're wrong. Restart yourself. We'll carry on without you. Let us know when you're back. And so the computer will restart itself, reinitialize everything, and basically pull its data from the other 2 computers and go, all right, I'm back now. I'm on your team. So they get, and that's the way they get around having to build radiation hardened computer equipment. Apollo cameras were stock with no added protection. I don't know the answer to that, but that'd be interesting. One of the cameras failed on Apollo, right? The which one was it? It was Apollo 17. They pointed it directly in the sun. Wasn't that a thing? I doubt they use GoPros, otherwise the Russians would probably do the same thing. Actually, the camera itself is generally not the hard part of getting the telemetry stream. It's really it's all the constant feeding of data that's probably the harder part. And that's why we always see the camera cut out on the drone ship, is because trying to keep a video feed, which is a huge amount of data, trying to keep a constant video feed with no interruptions, it's really difficult to do. So that's why we always see the drone ship video cut out. But they've been much better. No cutout today. That was nice. Why don't they launch smaller rockets from high altitude planes? Well, they're going to kind of do that. Virgin Orbit is kind of going to try to do that, but the problem is, here's a problem with launching a rocket from a plane. I say this all the time. Here's our landing replay again. Look at how blue that water is on landing from the engine exhaust lighting up the night sky. Look at no interrupted feed. A little bit of, not really. Boom. Shut down. Loved it. So here's the problem with launching a rocket from a plane. To go to space, you go up, but to stay in space, you go horizontal. And you have to go horizontal very, very, very fast. Remember, we just looked at the speed. What was it? Almost 17,000 miles per hour to be in orbit. That is where the majority of your energy is used, is to go horizontal. And so to build a plane that can carry the rocket, to lift it into orbit, that's not a huge advantage. You're increasing the complexity of it. It's just not, I don't know, to be honest, I'm not even sure why Virgin Galactic is even pursuing it, but it's just launching traditionally is a easier way to do it. And you don't get that much benefit by launching it from a plane. All right, so can I do that in Kerbal? I could probably do that in Kerbal. We should demonstrate that. That's a great demonstration. Let's do that in Kerbal. I should probably go to this view. Get rid of the replay text. Actually, before we do that, let's switch this over to live so that I know when they come back. But it's going to be a little while, but let's do that in Kerbal so I can show that to you. Because also, Justin Ford, another one of our YouTube members, thanks Justin for the support there. He said, can you launch it from a balloon? It's pretty much the same idea. They do launch rockets from balloons. Usually they're not orbital rockets. They're just little sounding rockets. They're called raccoons. But it's the same problem launching from a balloon versus launching from an airplane. You still need 17,000 miles per hour of speed. And really, like the vertical space there that the rocket goes up, like the rocket pretty much just goes, it just goes up just a little bit, like, that's it. And then it goes sideways for a long time. It only has to go up for a short amount of time. So really, they're in their orbital altitude within like 3 minutes. Don't quote me on that exact time, but might even be sooner than that. But they're in their orbital, they're pretty close to their orbital altitude in just a few minutes. The rest of the time is spent accelerating to get speed so that they stay in orbit. Getting to space is easy. Staying in space is the hard part. I say easy. Easier. So, let's demonstrate. Oh, actually, I gotta go back. We can demonstrate this, I think. Let's build a space plane. And let's show... Let's see. Let's start with one of their... Oh, no, not one of those. Let's start with an airplane of some sort. Maybe one of these? Maybe. That might do it. What do you think? We'll take one of these and then, like, just attach a rocket underneath it. I don't know if that'll work. This could be a disaster. But let's try it anyways. Alright, let's see. So we're going to need a attachment point here. We're just going to throw it... Do we throw it under the wing? Yeah, we probably should throw it under the wing. Like Virgin Galactic. Right? We'll throw it right there. Then we're going to need some fuel tanks. What? Oh, that is huge. That's way too big. Where can I download this? This is called Kerbal Space Program. You can go to kerbalspaceprogram.com and get yourself a copy. Wow, that's a huge rocket. And get yourself a copy. You can also get it from Steam, too. Liquid fuel fuselage. We don't want it to be too huge. Like, these are enormous rockets. We don't want it that big. We can't have it that big. It needs to be a little smaller than that. But, oh, there it is. There it is. Yeah, okay. It's kind of got a little bit of a downward slant. I feel like that's going to be a problem. Oh, there we go. Let's make it we'll put it on the leading edge of the wing. I'm sure that'll be fine for aerodynamics. Okay, let's put a nose cone on it. Is that no, that's too big. This one? Oh, that's way too big. Pointy one? Oh, yeah, come on. No, go. What are you doing? Okay, it doesn't want to. It refuses. Okay. I'm the boss. You do what I say. There we go. Okay. Should we make it a 2-stage rocket? I feel like it's not going to lift it if it's a 2-stage rocket. Let's see if we can do it single stage to orbit. That's tiny engine. Which engine do we want? This one, maybe? Yeah, we'll give it a giant engine. It's not the most aerodynamic, but let's see what happens. Maybe a second rocket on the other side for balancing, and a second try. It'd probably be the smart thing to do is to try to balance it out, but I feel like it'd be funnier if we don't. So, we're gonna try to fly it without... Oh, wait, I gotta turn the SpaceX music off. We're gonna try to fly it without the balancing act here. Do I have any sound? Let me see. What's my audio like? Yeah, okay, so we're good. Turn it up. Okay. Let's see what happens. Oh, yep, check your staging. Oh, man. Oh.
That is improper staging.
Yeah, that is improper.
That is improper staging.
That's exactly what that is. That's a...
That is improper staging.
Why didn't anybody remind me to check my staging? Okay, so that... that is not how you get to orbit in a space plane. We should fix that. Yep, so we're gonna do that, and we're gonna switch that around like that, and then we gotta do that, and then that, and then, yeah, okay. That's better. Let's try that. Makes the vomit comment look like a walk in the park, right?
That is improper staging.
That definitely was improper staging. That is not. That's not it. Okay. Now we got this. We got this. I feel good about this. I don't, but I'm gonna pretend that I do. Can we get rid of this? We don't want this mech jeb stuff. Get that out of here. Okay, we're good. Here we go. Engines on. Throttle up. Did we get ATC clearance? It doesn't matter. We're getting speed. There's no way this is gonna take off. Look at it, it's leaning to, it's already got a little to the right there. Look at look at how much it's leaning. There's no way. We're only going 50 meters per second. Oh, we just bounced the wing off the ground. Nope, we're rolling. It's rolling. I can't control it. No. And we're gonna cartwheel. Okay, we probably need a stronger plane. That's probably what we need. Fritz. Fritz says, told ya. I know, Fritz, you're right. You're right. We also need more boosters. By more boosters, I mean more engines. we're gonna put another engine or two on here. Do like that. Are those actually attached? Close enough. might wanna tie that down. Where's the zip ties tab? Yeah, here, let's zip tie them together here. Okay. Alright, and let's do what Fritz said, and we'll let's put a second one over here for balance. That's not gonna help me with actually lifting off, because we're a little bit heavy right now. But we might not have a choice, because let's do more. More! I need more. There. Are those actually attached? Zip tie all this together. Zzzt. Zzzt. There we go. Oh, nope, that didn't work. There. Okay. Looks good. With a bit of duct tape, we'll be good. You need ballast for the left wing weight. You're right. We just throw another rocket on, though. That'll balance it out. Don't tell him he's got 2 rockets on the right wing. Wait a minute, I don't have 2 rockets, do I? She needs more power! Oh my goodness, look at it bounce around. Look at it. Oh, she's rocking and rolling. God, is that the most god-awful thing you've ever seen? Look, it looks like it's shimmying. Like, we need different music, like... You see? That bounce. Here we go. Giddy up. Oh yeah. Oh, we already got more speed. We're doing better. We're already better, but we're not really going down the runway straight though, so we're gonna try to use all the runway. If we can. Here we go. Where's the runway end? There it is. Rotate. Uh-oh. 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 Oh, gear up. Gear up or something. Nope, we're going down. Oh, boy. We're rolling. We got it. We got it. We're okay. We're okay. Nope. 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 Roll it back. Okay. We're good. We're good. We're good. Climb. Climb. Our speed is decreasing. That's not good. That's not good. Is our gear up? Our gear's up. Okay. All right. Oh, wow. This is really hard to control. Okay. All right. All right. I got this. I got this. She is not stable. Okay. Okay. All right. We're flying. We need to gain some speed here. Woo! All right. We're okay. She is, like, leaning to the right a lot. Oh. Uh-oh. Uh-oh. All right. Can we climb? We're only at 700 meters. We gotta get... We're gonna need a little higher than that if we're going to space. Come on! Uh-oh! Oh, I do have 2 rockets on the right wing. You guys! What? Why did you not tell me that? And I didn't check my staging either. Guys! Oh, God, this is a disaster. Look at, there's two rockets on the wing. How did that even happen? This is not gonna end well. What are we at? Oh, look at, we're climbing 1,600 meters. Maybe can I just drop one? What happens if I just manually drop one? Enable decouple. Oh, yeah, there we go. Look at, ha, save the day. Oh, it's so much more stable now? Just by getting rid of that extra rocket. Oh, okay. All right. All right. Now we're talking. Look how much more stable it is now. Just had to... I'm gonna send that into SpaceX. Or Virgin Galactic. Listen. If you get yourself in a pickle, don't try to bring 2 rockets on one wing. It's not a good idea. There's better ways. There's better ways. You think they've thought of that? I should probably send it in. I'm gonna stall. I need more speed. I also need to, like... I'm trying to, like, change my staging at the same time. Oh... Okay, you just hang there for a minute. I need to... Okay, there. Okay, there. There. Alright, I had to fix the staging there a bit. Okay. Wow. Alright, you know, I just discovered, though, there's gonna be a problem here. I'm not gonna be able to control the rocket, am I? Maybe I can. Maybe I can say control from here. I didn't put a control module on the rocket. That's a problem. Well, shucks. Uh-oh. What happened? Oh, I hit the wrong button. Okay, wait a minute. You know, I think we ought to just... Let's just light him up. Then we gotta fix this. We need a control module. How fast do you think we can get this plane going? Yeah, alright, let's see that. Then we're gonna have to redo it. Okay, here we go. 3, 2, 1. Nothing happened. Oh, oh, there it is. Oh, yep. Oh, now we're out of control. Yeah, that's just... that is not... no, that's not what we planned on. It's not quite what I was going for. It's not exactly... Huh. Yeah. Oh, and they burned out already. Yeah, that was pretty quick. See ya. Oh, oh, oh. Alright, well. That's a shame. And now we're stalling. We're literally just falling through the air. I have no control. We're just falling, and I can't control it. Can we shut off the engines? Will that give us some control back? Nope. We're going 65 meters per second backwards, tail first. Alright, we're gonna try this again. We need to try again. How are we doing on time? 53 minutes. Oh, did anybody hear about a fairing catch, or were you guys too busy watching me? Oh no, we weren't doing a fairing catch today. Never mind. They're picking them out of the water. Sorry, I already forgot. We're not doing a fairing catch. Forgot already. Alright. Okay, so if I'm gonna control one of these rockets... Look, why do we have 2 of those on here? Okay, you... Goodbye. We don't need 2. We need some sort of, control mechanism. Can we just put like a command pod on it? I'm gonna put a Kerbal on it! Also, I feel like we don't have nearly enough fuel, but if we start adding more fuel, like, there's no way I'm gonna get it off the ground. Let's see. Inline cockpit? Oh, there it is. There it is. Look at that. It's like a little mini something. Look at that. Now it's like way too far forward, though. Gonna get some of that weight towards the back a little bit, eh? Not quite what I was going for. Come on. Alright, hold on here. Why can't I do it? No, we need a second one of those. We need symmetry. Okay, let's do this. Get rid of... Is that attached? Oh, that looks all right. Yeah, okay. Okay. All right. All right. What if you set them a bit wider? Do we want wider? I thought we'd want them closer to the center. But I'll be honest, I have no idea. You guys tell me in the comments. Should it be wider or towards the center? Check the angle. Yeah, it's kind of straight now. We're gonna see what happens. And we can, okay, yep, that's all fine. Okay, good. Perfect. Well, maybe not perfect, but check your staging. Probably a good idea. Okay, so first thing we need is going to be jet engines. Okay, you down there. You guys down there. You guys down there. Then we're going to do one rocket. And we need, so that's the rocket on the right. So we need the separator on the right, and that'll give us one other extra to play around with. Okay. Let's try it. Worth a shot, I'm no rocket scientist. This is a pretty elaborate way to kill Kerbals. It is, right? I feel like... Do we have more dramatic music than this? Here we go. Now we're sending them. Full send. We got this. Oh boy. Oh boy. Turn down the music a bit. Oh boy. Yeah. We got the beats going now. Rotate. Giddy up. Look at us go. Oh, we're flying. Oh, baby, gear up. Oh, now we're talking. Look, Ma, no hands. Oh, we're so stable now. Dublin says it's almost better than the actual rocket launch. I wouldn't take it that far. All right, what altitude should we go to? Oh, we are decreasing in speed, aren't we? What? I don't know what the stalls. What's the stall speed for a Kerbal Space plane with 2 rockets on the wings. We're only at 4,000 meters. All this to demonstrate why launching rockets from under the wing of an airplane is silly, in my opinion. Sorry, Virgin Galactic. I'm just not on board with this idea. Alright, we're gonna pitch down a little bit. There we go. We'll increase our speed a touch. Right. Oh, there we go. Now speed's increasing. We're okay. 20-degree climb angle. We're okay. We're good. How's SpaceX doing over there? They're okay? Yeah, they're good. Oh, they should be back any minute. Oh, come on, SpaceX. I'm in the middle of something now. Ugh. Not nearly high enough. Alright, well, I'll just let it climb. Maybe when SpaceX comes back, we'll just let her keep going. Might stall it, but... How much longer we got? Second stage restarts any minute. Let's pause this for a minute. SpaceX hasn't come back yet, but they will. They'll be coming back in a second. I'll listen in. I think I got it muted to you guys. But now you can't hear the Kerbal audio, but that's okay. You just hear me and our killer tunes. Are they back yet? They're supposed to be back. Losing speed? Oh, I am losing speed. Let's pitch down a bit more. There we go. Thank you. They should be back soon. Yeah, we're gonna lose speed. Oh, they're back. Okay. All right, back to the real stuff.
Had a smooth on-time liftoff at 6:24 p.m. Eastern Standard Time. 2.5 minutes later, we separated the first stage from the second stage. The second stage then completed its first burn, successfully inserting the GPS with the second stage still attached into the planned parking orbit. Now we're coming up on the second burn of the upper stage engine in about half a minute. Flight computer is currently commanding settling thrusters to turn on and off. That's releasing nitrogen gas out of 2 thrusters in the back of the second stage that lightly pushes the stage, and that helps keep the propellant at the bottom of the tank right above the inlets to the engine's turbo pumps. As you can see from the ground track, we're passing south of the Tasmania ground station in Australia. Following the burn, we'll be headed in orbit up towards the Hawaii and Vandenberg ground stations. Awaiting for ignition.
Here we go.
MVAC ignition.
Wonder if it'll
We've
show
got
on our
ignition
telemetry.
of the second stage engine. We're up on power. Now, the second stage will burn for 45 seconds.
Not
We're going to
showing
be
there.
adding over 2,000 meters per second to the speed of Falcon 9 before we shut it down for the second time. You can see from the velocity meter on the screen the speed clicking up. We're still at 419 kilometers in the same altitude in the parking orbit where we've been for a while. But this burn is going to bring us all the way up into the transfer orbit, and then shortly after that, we'll separate the GPS satellite. Now we're coming up on shutdown number 2 called SECO 2, and this is the burn that will place GPS-3 space vehicle into the required orbit.
MVAC shutdown.
We've got SECO, MVAC shutdown call out. We're waiting for the orbit.
nominal insertion orbit.
That's
The
weird.
guidance, navigation, and control engineer has called out a nominal orbit. Looking at the data, it's an excellent looking orbit. So second stage in a good orbit, GPS spacecraft is still attached to the Falcon 9 at this time. Now we're going to go through a series of events to get ready for separation. A little bit after we have finished a short coast, we are going to start a slow spin of the second stage. That's going to help stabilize the GPS satellite when it's released from the second stage. We also have to wait until the orbit takes us into range of the 2 Air Force satellite ground stations, one in Hawaii, one in California. We've got to make sure that the ground stations can be in contact with the GPS satellite before we release it. So all of this is going to take 24 minutes to get into the right situation at the right spin rate. And that satellite separation is planned to occur at about T plus 1 hour and 29 minutes. So we're going to pause the commentary now during this coast, but we will come back just before planned separation in about 23 minutes. We'll be back with you at T plus 1 hour, 28 minutes, and 30 seconds.
Okay, so they'll be back. We can return to the Kerbal dance party, as Anita says. Back to Kerbal. Okay. Check them out in a minute. Let's see, let me mute that. Come back to here. So we can turn that up a bit. Okay. We're still climbing. What are we at? 5,400 meters. It's not very high. That's only like, what is that, like 15,000 feet? Ish. That's not a lot. We're not even at like regular cruising altitude. But we are carrying, you know, 2 giant Tundra rockets here. Oh, hey, there's the moon. We should take a screenshot of that. Like, that's cool looking. Gonna take a screenshot. Boom. Or with the Milky Way there. Make this the thumbnail of the video. People will be very confused. SpaceX GPS-3 launch. Followed by a thumbnail of a cobbled together space plane and with rockets under the wings. What in the world? I am not watching that video. No way I'm subscribing to that crazy YouTuber. And our speed's going down again. We gotta pitch down a touch. We're only at like a 10-degree climb angle. So we're not climbing very fast. I don't know what we're gonna be able to do here. Uh-oh. I can't even climb anymore. Yeah, now we're struggling to get lift at all. Well, we're about 20,000 feet, right? A little less, maybe, I don't know. 6,000 meters. Oh, now we're going down. We're really struggling to get lift. All right, we're gonna have to send one of these rockets. Let's send it. How do I quick save? What's quick save? F5? There we go. Quick save. Just in case we want to try again. All right. So which rocket's coming first? The one on the right. Okay. Let's see. Control from here. Okay. Control from there. We're not very high, but I know I'm not very high, but I can't get any more lift. We just gotta send it. We're just gonna go for it. Okay. That's what's happening here. Take one more screenshot. Just for good measure. Okay. Oh, this is gonna be such a terrible idea, but... Okay. Here we go. So what's the best way to do this? I think I'm gonna try to like have a super pitch backwards and then just go for it, I think. I don't know. Should we do our dramatic music again? Let's go back to that original song. What was that? Yeah, this one. Oh, what happened? go. Uh-oh. Oh, no. I thought I was controlling from there. Oh, no. Get it back. Get it back. Oh, no. Oh, no. Oh, man. Turning off the music. Load the quick save. That was not good. That was terrible. We need it. Didn't I say control from here? Or do I have to do something different to control it from here? Transfer crew. Okay, crew getting no crew on part. Yeah, okay. Control from here. That's where I want to control it from. Control from here. Yeah. Okay. Maybe I can't. Let's try this again. If I just jettison. Nope. And now we're in trouble. Oh man, I really thought that would work. Huh. You may experience some slight turbulence. Oh man, I thought that would work. Maybe it's because I don't have the lights on. Okay. Maybe, just maybe, if I like, give it one of these. Okay, then escape. You're in flight. Game cannot be saved at this point. No, I can't do that. Control it from there. No. Oh, God. The engines don't even ignite. Hold on. Maybe we need to ignite the engines first. I don't think that's going to work, but it's what I'm going to do. Just do them in rapid succession. Control from here. Oh, well, we sent it. There it goes. Not exactly. Well, that was a big bust. We're just sending missiles in the distance here. They're just completely uncontrolled. There's got to be something we can do for this. Why can't I can't revert the flight? Oh, probably because I did a quick save. We'll go back to the Space Center. Oh, I didn't even save this rocket, did I? Alright, I have to, like, intentionally crash it. Let's just nosedive it! Here we go! Oh, look at I can't even nosedive. Come on! Oh, yep, oh, Alright, let's just shut the engines off. Let's get in a stable radial in position. Maybe we want radial out? No, we want radial in. I can't do anything. We should have put RCS thrusters on it. That's what we need. More thrusters. You're fired. What? Come on. I'm doing a great job. Look it. Lorena subscribed. Why, Lorena? Why would you subscribe to this? This is ridiculous. Thanks, Lorena. I appreciate you being here, but how are you doing this simulator? This is called Kerbal Space Program. Can you use bracket or bracket to select each rocket individually? I don't know. Now I can't do any. Okay. Can we go? Oh, I can't even go back to the. Okay. That's a problem. We lost our Kerbals. They knew what they were signing up for. All right, here's what I think we do. We build the rocket, and then we'll, like, build the plane around it or something? I don't know. You couldn't control it from there because there were no crew in it? Is that what I have to do? I didn't even save the rocket, so we have to build it again. Son of... Well, that plane wasn't doing it for me anyways. Well, that one's tiny. That's not going to do it. It's this one. Well, that's like a fighter jet. Strato... Oh, they have a Strato launcher. Guys! They have one already built. Why did nobody tell me this? They have a stock one in the game. Why are we messing around when there's a stock one in the game? Come on, guys. Who's in charge here? Oh, man. Really? There's one in the game. Oh, we spent... Ah. I'm firing a producer. You're fired. You guys just wanted to see me ride the struggle bus here. Unreal. It's already, the staging is already set. Now we got this.
Lobster Fest is on.
Let's do it. Okay. How much time do we have from SpaceX? Couple minutes. We got little 10 minutes or so. Okay, now I'm feeling good. We're going back to the original song again. We're going back to the original. Here we go. I love this song. This is like my hype song. Gets me pumped. It's gonna deorbitate. Oh, it's taken off by itself. Oh, jeez. Oh, jeez, look at it go. I wasn't even paying attention. It's already flying. Holy smokes, okay, sure. Here we go. Look, this is much better. We should have done this to begin with. Oh, and they also did something very smart. Look at, they didn't fill the thing with fuel. It was a lot lighter. Anita says you can't fire the producer. He's gonna be paid by us members. All of a sudden, it's a members show, and now you guys are in charge. Look at that, you're at the same altitude. Look at that, I passed the altitude we were at before, like that. Well, that was just silly. Oh, look at, we got flaps and everything. Are they deployed? What are they? We're just kind of... We're pretty much going, like, straight up at this point. And we're... Oh, no, we're decreasing in speed. This thing is like a rocket. By itself. Alright, what kind of altitude we gotta get to? This is like... So this is like plane cruising altitude here, right? We're 10,000 meters? 10 kilometers? We're kind of yawing to the right here. Not sure why. Okay, let's climb this up a little high. We can go higher than this. What's the title of that song? My jam that I was doing? It's a Harris Heller song from his stream beats called Neon Renegade. Oh. No, stop it. Alright, we might have to send it here. We're not really climbing very fast anymore. All right, I think we're gonna send it. Let's quick save it. Here we go. Oh, let's take a screenshot first. Okay, ready? Send it. 3, 2. Oh, I got no control over it. I can't pitch up. Okay, well. Oh boy! Yeah! Oh! Look at that! Oh, it's working. Oh my goodness. Oh, yeah! Look at us go! We're going to orbit! Look at us go! Oh, uh-oh. Oh, look at that. Oh, little tiny engine there. Yeah, all right. Now we're talking. Look at our apogee's already at 50 kilometers. Oh, here we go. Atmospheric heating. Not good. We're going to push through, though. Look at... Oh, actually, we can kill it. We're at 80 kilometers is our... Here, we'll throttle down. We're in the throttle bucket. We could actually... See, this is the point. This is what would confuse all our people. We can actually pitch down at this point. To get our... To circularize our orbit, but not increase our apogee. It's a little too much. There it is, right about there. That's almost perfect. So we're pitched down. We're pitched down like 12 degrees to the horizon or so. But it's bringing up our perigee. If you look up here at the... I don't know if you can read those numbers. They're pretty tiny, but... Oh, now we're... Oh, there's our payload fairing. We're not in orbit. We're still suborbital, but... Oh, this thing's got its own little engine. How about that? Oh, it's like an ion engine. That's not going to give us much speed. Are we going to get to orbit with that thing? We'll try. Might be tough. How's SpaceX doing? Oh, we got time. What is that supposed to be? I have no idea. I don't know what this is. It's just a little satellite. This is our Virgin Galactic. We're not... I don't think we're going to stay in orbit, though. We're going to be suborbital. See, this is why launching rockets from airplanes is tough. It's so hard to lift that rocket, and we still didn't get enough. Oh, I'm running out of electric. Do I have solar panels on here or something? Extend solar panel. I do. Well, how about that? Extend them so we can get some power. Okay. Yeah. There we go. Now our batteries are... Well, they're not charging, but... They're still being depleted. Did I miss payload separation? No, we haven't. We got a couple minutes, about 5 minutes to SpaceX's payload separation. Pitch up. Actually, I want to pitch down just a touch. Because we're still trying to... We're trying to get that perigee up so that we stay in orbit. We might do it. Maybe. Actually, I'm gonna run out of electric power here. What is that gonna do? Yeah, look at our engine's spitting and sputtering and just gonna die here. Sun exposure 0. We're on the wrong side of the Earth. We need sun. Well, that's a problem. It shouldn't be. I don't know why. Oh, there we go. SpaceX is back to the vehicle cam. All right. Are they talking? No, it's just music. Just music, so we'll keep going. We got some time. We still got about... Deployment's not for another 4 minutes here. So we got time. All right, we're gonna... Actually, we want to pitch... Oh, we're rolling. I don't want to do that. Oh... This might get to orbit. You should make a side carrot flag for the flag. That's not a bad idea. I have a space lobster flag that I think, I want to say Gregorius made for me. There we go. There's our GPS satellite and our camera views. They're still playing music, so I can't switch back to them yet. This might get to orbit. Look at our perigee still is negative 80 kilometers. Basically means we're suborbital. Deployment here is in 3 minutes. 3 minutes from SpaceX. Can we get orbital in 3 minutes? I don't know. How are we doing on our orbital trajectory? Look at this. Look at us go. This is not bad, actually. We're almost there. Negative 26 kilometers. Our climb rate is kind of decreasing a little bit here on the perigee. Maybe I should do something like this. Oh, no, definitely not that. Definitely not that. Oh no, our perigee's increasing. Oh no, we're out of control. That's because we're re-entering the atmosphere. Oh no, oh no. Oh no. Oh man. Oh! Yep. And that's a problem. Okay, well. It was fun while it lasted. Throttle off. I can't. I'm out of control now. Oh, there we go. Yep. Ah, well, we did all right, I think. Let's go back to SpaceX now. See what they're up to. Okay. So we're coming up.
Coverage of the GPS-3
Oh,
Space
jeez.
Vehicle 4 mission for the US
Hold on.
Space Force.
Mute that.
If you're just now joining us, we had an on-time launch at 6:24 p.m. Eastern Time, followed by a successful ascent, stage separation. First stage came back and landed on Of Course I Still Love You, and 2 second stage engine burns. We have just one more major milestone coming up to complete today's mission, which of course is the deployment of the GPS-3 satellite from Falcon 9's second stage, just about 15 seconds from now. Currently, the second stage is rotating to stabilize the GPS-3 satellite, and we're currently in view of those 2 customer ground stations on the western U.S. that John mentioned earlier that are necessary to connect to prior to deployment today. We've got a nice live view of that GPS-3 satellite.
Payload deploy confirmed.
There she goes.
And there confirms the deployment of the GPS-3 satellite as it's drifting away from Falcon 9 with a nice sunlit view there. This confirms a successful spacecraft separation, and that completes our primary mission, which will bring today's webcast coverage to a close.
And it's a great view of the GPS satellite drifting slowly away from the Falcon 9 second stage, and it's a great way to bring a webcast to an end. We'd like to thank the U.S. Space Force for entrusting us with today's GPS-3 Space Vehicle 4 mission. And we look forward to the additional GPS missions we will be supporting in the future. Special thanks this evening to the 45th Space Wing for range support, and to all of our viewers, thanks for joining us for today's mission, and have a good weekend.
All right. Well, there we go. We still got our bumping tunes going. Let's go back to our chill stuff. There we go. All right. Well, that's gonna be it here. We had a good mission. We had some fun with Kerbal. I might stick around and do some more Kerbal for any of our Patreon members that want to jump on our Patreon voice hangout in Discord, because I'm going to try that again. But I'm probably going to end the broadcast here. But I appreciate everybody for hanging out. That was nice. Nice little GPS launch. Remember, this deployment was in an eccentric orbit, an elliptical shaped orbit. So the maximum altitude, the apogee of this orbit is about 20,000 kilometers. But this orbit today, the Falcon 9 dropped it in, is 20,000 at its apogee, but 1,000 kilometers at its perigee, its closest point to Earth. So it's in this very elliptical shaped orbit, and actually you could see the onboard engine there that, I don't know what these thumbnails are that we're seeing, but the you can see the engine here on the back of the GPS satellite itself right there. And that is going to finish the job there and get it to a circular orbit, 20,200 kilometers by 20,200 kilometers. Eventually. We're not there yet, but it's 20,200 kilometers by 1,000 kilometers right now. That's where the SpaceX Falcon 9 has dropped it off to. But successful mission. We had a little bit of a bumpy road here on the broadcast today, at least at the beginning of it. But if you're watching the replay, you're never going to know, because I'm going to trim it out. You're not going to see it. But everybody that was here live saw a train wreck in action. Anyways, so I'll probably continue. We're going to mess around with, we'll probably do one more Kerbal flight and see if I can get that thing into orbit over with our Patreon members on Discord. So consider becoming a Patreon member. If you're a YouTube member, you also get access too. You gotta be a YouTube rocket engineer or higher, and you can also get engineer too. So you don't have to be a Patreon member. You could be a YouTube member, and you also get access. You just have to make sure that your Discord account is connected with those, and then you get the access to the super top secret stuff on Discord. But if not, and that's not your thing, no worries. No big deal. I just appreciate you being here anyways. I'm happy that you're here with us. And I'm happy that you're here watching, taking part, chatting. Chatting helps. It's all a big help. Everything Space. Are you going to stream the news conference pre-Crew 1? I don't know yet. Maybe. We did that last time. We might do it again this time around. I got to look at what the schedule is coming up, but I would say maybe. We're definitely going to stream. We'll be here for Crew 1, of course. About 5 hours early. We'll be here for Crew 1 again. And Crew 1 is November 14th at 7:49 p.m. Eastern Time. What's that, 23:49 UTC? Did I do that math right? Is that the right time? But we'll be live 5 hours prior to that, around 2:45, 3 o'clock-ish Eastern Time on November 14th for the Crew 1 mission. So, that's it. Thanks for another great stream. Thanks, Anita. Appreciate it. It's a long deployment here today, but I think we had some fun dealing with this. didn't really leave it in good shape, but yikes. All right, everybody. I think I'm going to end it right there so that I can let the stream render and then I can trim out that beginning section and we're going to pretend never happened. It'll just be our secret. And if you weren't here for the beginning and you don't know what I'm talking about, don't rewind. Don't go back. It's not good. If you are watching the replay, you're going to be very confused because you're not going to be able to rewind it. All right. Thanks, everybody, for hanging out. We'll see you again, I'm sure. My name's Tori. This is Overlook Horizon. And I will see you next time. Thanks, everybody. Goodbye.